200 pairs an hour. That's how many sneakers can roll off a single production line in a modern factory. One fresh pair hitting the conveyor belt every 18 seconds. But here's the thing, each one of those shoes is a masterpiece of precision engineering, robotics, and material science that would blow your mind if you saw it up close. Today, we're stepping inside the factories where Nike, Adidas, and New Balance turn raw materials into the kicks on your feet right now. Forget everything you think you know about how sneakers are made. We're not talking about rows of workers hand-stitching shoes anymore. Modern sneaker factories are part sci-fi laboratory, part high-tech assembly line, where giant robotic looms knit entire shoe uppers in minutes. Machines inject molten foam at 800 kilograms of pressure per square centimeter, and robotic arms apply adhesive with surgical precision. This is manufacturing at its absolute cutting edge. Let's start where every sneaker begins, with a single thread. The upper, where giant looms knit your shoe in one piece. Picture a machine the size of a small car, loaded with spools of colorful yarn, humming as it weaves your next pair of running shoes into existence. This isn't your grandmother's knitting machine. This is a CNC, computer numerical control, knitting machine, and it's creating what Nike calls fly knit and Adidas calls prime knit. Here's where it gets wild. Traditional shoe uppers require cutting dozens of separate fabric pieces, then stitching them together one by one. A typical sneaker might have 32 different components that need to be assembled in a precise sequence, but fly knit technology throws that entire process out the window. Instead, a computerized flat knitting machine creates the entire upper as a single, seamless piece of fabric. The machine is loaded with polyester, nylon, or spandex fibers, sometimes up to 10 different colors at once. The newest knitting machines can handle multiple fiber types simultaneously, mixing materials with different properties into the same upper. Want a stretchy mesh section for breathability over your toes? Done! Need reinforced support around the heel? The machine knits it denser. It's all controlled by computer software that tells each individual needle exactly when to knit, tuck, or skip. But here's the million-dollar question. How does a flat knitting machine create a three-dimensional shoe upper? The secret is in the shaping. Modern flat knitting machines can create what's called fully fashioned construction. They knit the shape directly into the fabric by adding or dropping stitches as they go. The upper comes off the machine already curved and contoured to fit the human foot with closed edges all around. No cutting required, no waste. The machine even weaves in support cables and reinforcement strips as it knits. These aren't added later, they're integrated directly into the fabric in real time. Watch one of these machines in action and you'll see the fabric literally growing before your eyes, layer by layer, row by row. The knitting head moves back and forth at speeds up to 1.6 meters per second, and depending on the complexity of the pattern, a single upper can be completed in anywhere from 30 minutes to a couple of hours. Once it's finished, the upper gets pulled off the machine, and unlike traditional cut-and-sew construction, there are almost no scraps left behind. The environmental impact? A fly knit upper reduces waste by about 60% compared to traditional methods. One machine, one piece, minimal waste. That's the future of shoe manufacturing. The sole injecting clouds of foam at 1,200 bar pressure. Now let's head to the other end of the factory where the magic of cushioning happens. If you've ever wondered why modern running shoes feel like walking on clouds, you're about to find out. It all starts with tiny white pellets of EVA, ethylene vinyl acetate, a foam material that's become the gold standard for sneaker midsoles. The process is called injection molding, and it's equal parts chemistry and precision engineering. Here's how it works. Those EVA pellets get loaded into a hopper and fed into a heated injection unit. The temperature inside that unit climbs to between 160 and 200 degrees Celsius, hot enough to melt the EVA into a semi-liquid state. Too hot and the material decomposes. Too cool and it won't flow properly. The temperature control has to be absolutely perfect. Once the EVA reaches the right consistency, it gets injected into a metal mold at pressures ranging from 600 to 800 kilograms per square centimeter. For perspective, that's roughly equivalent to the weight of a small car pressing down on every square centimeter of the mold. At some facilities, like the ones producing premium performance shoes, the pressure can reach as high as 1,200 bar. This extreme pressure forces the molten EVA into every tiny detail of the mold cavity, ensuring consistent density and perfect replication of the sole design. And here's where the science gets really cool. Mixed into those EVA pellets are two secret ingredients: a blowing agent and a cross-linking agent. When the molten EVA hits the heated mold, which is maintained at around 170 degrees Celsius, the blowing agent decomposes and releases gas bubbles. Think of it like baking a cake. The heat activates the leavening agent, creating air pockets throughout the material. But unlike a cake, we can't just let these bubbles expand randomly. The mold is designed to open rapidly at precisely the right moment, allowing the trapped gas bubbles to expand in a controlled way. As the sole ejects from the mold and hits the air, it literally puffs up, sometimes doubling in size. Meanwhile, that cross-linking agent is forming chemical bonds that stabilize the foam structure, locking those air bubbles in place and giving the sole its characteristic bounce and cushioning. The entire injection molding cycle takes about 20 minutes per piece. For popular sizes, factories will run multiple molds simultaneously. Otherwise, production would be painfully slow. The result? That bouncy white foam sole that cushions every step you take. Some manufacturers have taken this even further. Adidas developed Boost technology, which uses thermoplastic polyurethane pellets instead of EVA for even more energy return. New Balance has experimented with 3D printed resin soles called triple cell, but EVA injection molding remains the workhorse of the industry, combining performance, cost-effectiveness, and scalability. The glue, when robots apply adhesive better than humans ever could. Now comes one of the trickiest parts of shoe manufacturing, getting that upper and sole to stay together permanently. For decades, this was done entirely by hand. A worker would grab a bottle of adhesive and squeeze it around the perimeter of the sole, trying to apply an even bead of glue without smearing it everywhere. The results? Inconsistent at best, glue would end up in the wrong places. Too much in some spots, not enough in others. Enter the robots. Modern sneaker factories now use vision-guided robotic arms for glue application, and the precision is absolutely incredible. Here's how it works. As each sole arrives at the gluing station on a conveyor belt, a 3D vision camera scans it while it's still moving. The camera captures a point cloud, essentially a three-dimensional map of the sole's exact shape and position. This is crucial because not every sole is perfectly identical and they're not always oriented the same way on the belt. The vision system's algorithm processes that point cloud data in milliseconds, identifying the exact edges of the sole and calculating the optimal trajectory for glue application. It compensates for any irregularities in the sole shape or positioning. This trajectory gets converted into robot coordinates and transmitted to the robotic arms controller. No manual programming required. No skilled robot operator needed on the factory floor. After the robot applies glue to the sole, another robot, or sometimes the same one, does the identical process for the upper. Two precise glue paths, perfectly aligned, ready to bond. The oven, baking shoes to seal the deal. You might think the next step is just pressing the upper and sole together. Not so fast. That glue needs to be activated first, and that's where the heat comes in. The glued components travel down the assembly line on a conveyor belt into what looks like a giant industrial oven. This isn't about cooking the shoe. It's about activating the thermoplastic adhesive. These heat-activated adhesives remain dormant at room temperature, but when exposed to specific temperatures, they become incredibly tacky and form molecular bonds that are nearly impossible to break. The assembly line, orchestrating chaos into 200 pairs per hour. Now let's zoom out and see how all these processes come together. A modern sneaker assembly line is a carefully choreographed ballet of humans, machines, and conveyor belts. At New Balance's Lawrence, Massachusetts factory, every worker on the line spends an average of just 22.5 seconds on each shoe before passing it to the next station. That's not a typo, 22.5 seconds per worker per shoe. The 3 production lines running identical products in different sizes and colors, all moving in perfect synchronization. From the moment raw leather gets cut on the CNC cutting machine to the final lacing and quality inspection, each pair passes through a 55-step process involving 220 workers on a single shift. The conveyor belt is the unsung hero of this operation. Using stepless variable speed motors, the belt can be adjusted to match the pace of production, sometimes crawling along at a deliberate speed for complex stitching operations, other times zipping components from station to station. The belts are made from materials that can withstand high temperatures as they pass through drying ovens and heating chambers. In the fully automated speed factory concept that Adidas pioneered in Germany and Atlanta, the workforce was even smaller. Just 160 employees producing 500,000 pairs annually. That's over 3,000 pairs per worker per year. The robots handled the heavy lifting, laser cutting, precision gluing, heat bonding. Humans focused on quality control, machine operation, and the few tasks that still require human dexterity like lacing and final inspection. Here's what's mind-blowing. In traditional Asian factories, it can take 60 days to manufacture a shoe from start to finish, then another 60 days to ship it to Western markets. In a speed factory, Nike is one of the most recognized names in sportswear, and its shoes are known all over the world, not just for their style, but also for their performance and durability. Behind every pair of sneakers lies a fascinating and highly sophisticated manufacturing process that combines science, technology, human craftsmanship, and global logistics. From the very first sketches of a new model to the moment the shoe appears on shelves or arrives at your doorstep, there are countless steps and thousands of people involved. This is the story of how Nike shoes are made inside the factory, step by step, and why their creation is such a remarkable example of modern industrial design. It all begins with design. Before a factory even produces a single pair, Nike's team of designers and engineers work together to conceptualize the shoe. They think not just about aesthetics, but also about functionality, comfort, and innovation. Designers consider the needs of athletes and everyday wearers, combining elements of sports science with current fashion trends. The process starts with sketches on digital software where different shapes, sole patterns, and material combinations are tested virtually. Special attention is given to biomechanics, how the foot strikes the ground, how weight is distributed, and what materials can maximize energy return or reduce strain. This design phase can take months, and prototypes are often made using 3D printers so that engineers can hold and test a physical model before the shoe goes into mass production. Once a design is finalized, sourcing begins. Nike works with suppliers around the world to gather the materials that will become the shoe. This includes synthetic fabrics, genuine or vegan leather, rubber compounds, adhesives, foam, and advanced textiles such as fly knit. Sustainability has become an increasingly important part of the process, so factories now incorporate recycled polyester, environmentally friendly rubber, and other eco-conscious materials. Every material goes through rigorous testing to ensure it meets Nike's quality standards. Samples are stretched, compressed, bent, and exposed to heat and moisture to simulate years of wear in just a few days. Only after passing these durability and safety tests are the materials approved for use in the factory. The actual shoemaking process begins with cutting. Large sheets or rolls of fabric and leather arrive at the factory, and specialized machines cut out precise patterns for each part of the shoe. The cutting process has evolved tremendously thanks to computer-controlled lasers and automated presses, which can produce thousands of identical pieces quickly and with minimal waste. Human workers still play a crucial role in inspecting each cut piece for imperfections, ensuring only the highest quality parts move on to the next stage. After cutting, the pieces go through stitching or bonding. This is where the upper of the shoe, the part that wraps around the foot, takes shape. Skilled workers operate industrial sewing machines to stitch fabric, mesh, and reinforcement panels together. In the case of Nike Fly Knit shoes, advanced knitting machines weave a single seamless piece of textile that forms the entire upper. This eliminates extra seams and reduces weight while also cutting down on waste. Every stitch is carefully placed to balance flexibility with support, ensuring the shoe holds up under stress without sacrificing comfort. Next comes the assembly of the midsole and outsole, arguably the most critical parts of a Nike shoe. The midsole is responsible for cushioning, while the outsole provides traction and durability. For midsoles, Nike often uses foam materials such as Phylon or polyurethane. In some models, iconic Nike Air units, transparent pockets filled with pressurized gas, are inserted into the midsole. These air units are manufactured separately in specialized facilities before being shipped to shoe factories. They're tested for strength and consistency, since they need to withstand thousands of foot strikes without losing their cushioning effect. The outsole, usually made of durable rubber, is molded into specific patterns that provide grip for running, basketball, soccer, or casual wear. Molds are heated and pressed into shape, and then the outsoles are cooled and trimmed. Engineers design these traction patterns with careful consideration of the sport the shoe is meant for. For example, basketball shoes have pivot points for quick turns, while running shoes prioritize forward grip and flexibility. When the upper, midsole, and outsole are ready, the lasting process begins. This is where the shoe really takes shape. A shoe last, essentially a foot-shaped mold, is used to give structure to the upper. Workers stretch the upper over the last and attach it temporarily, ensuring the shoe has the correct size, shape, and fit. Then the upper is glued or stitched to the midsole. This is one of the most precise steps, as even a small misalignment can affect comfort and durability. Adhesives are applied carefully, and heat or pressure is used to bond the pieces together. After bonding, the outsole is attached. Industrial presses apply heat and pressure to fuse the rubber sole to the midsole and upper. Workers check alignment carefully to ensure everything lines up correctly. Depending on the model, extra stitching or sidewall details may be added for reinforcement. The finished structure is now starting to look like a real Nike shoe, but it still goes through a series of finishing steps before it's complete. At this stage, additional components such as insoles, tongue padding, heel counters, and laces are added. Each of these has been designed and manufactured separately to match the shoe's specifications. Branding elements like the iconic Nike swoosh are carefully applied, sometimes stitched, sometimes heat-pressed, or even woven directly into the fabric in fly knit models. Quality control inspectors check every detail, from the placement of the logo to the smoothness of the seams. Any shoe that doesn't meet Nike's strict standards is rejected or recycled. Once assembly is complete, shoes go through final quality testing. Workers flex the shoes, inspect stitching, measure weight, and check comfort. Advanced machines simulate running or jumping motions to ensure the shoes will perform as intended. Random pairs are even cut open to check the placement of air units or internal reinforcements. Nike's reputation depends on consistent quality, so this stage is taken extremely seriously. After passing inspection, shoes are cleaned, polished, and packed. Each pair is placed into a shoe box, complete with tissue paper and size labels. Boxes are then stacked into larger cartons for shipment. Nike's global logistics system then transports these cartons from factories, often located in countries like Vietnam, Indonesia, and China, to distribution centers around the world. From there, they are shipped to retail stores, online warehouses, or directly to customers who order through Nike's website. Behind this efficient process is a massive workforce. Tens of thousands of people are employed in Nike's manufacturing supply chain, from engineers and designers to factory workers and logistics managers. Although automation has transformed many stages of production, human craftsmanship remains essential, particularly in stitching, quality inspection, and finishing details. Every pair of Nike shoes carries the imprint of dozens of hands that shaped, stitched, checked, and packed it. Nike has also invested heavily in sustainability initiatives. Factories are now required to reduce waste, recycle water, and cut carbon emissions. Programs like Nike Grind recycle leftover rubber and foam into new products, including playground surfaces and sports courts. Flyke technology, by creating uppers from a single knitted piece, has reduced fabric waste by billions of pounds since its introduction. These efforts reflect Nike's growing recognition that the future of sportswear depends not only on performance and style, but also on protecting the planet. Nike shoes are more than just footwear. They represent innovation, global cooperation, and cultural impact. Each pair tells a story of design excellence, advanced materials, skilled labor, and precise engineering. When someone laces up a pair of Nikes, they're not just wearing a product, they're stepping into the result of years of research, testing, and craftsmanship. From the roar of the factory machines to the hands that tie the last knot, every step in the process contributes to making a shoe that inspires athletes and everyday wearers alike. And so, the journey of a Nike shoe from concept to completion is a remarkable one. What begins as a digital sketch on a designer's screen becomes a physical product worn by millions. Along the way, it passes through countless hands, machines, and tests, ensuring every pair meets the standards of comfort, performance, and style that have made Nike one of the most influential brands in the world. Whether on the basketball court, the running track, or the city street, each Nike shoe carries within it the invisible story of the factory floor where it was born. What makes Nike's factory process even more impressive is how it balances tradition with innovation. While highly automated machinery handles cutting, molding, and pressing, there's still a strong reliance on human skill and precision. A trained worker can spot a tiny flaw in stitching or alignment that no robot can yet detect. In many factories, you'll see rows of workers bent over their stations, guiding fabrics through powerful sewing machines with practiced movements. Some workers specialize in attaching swooshes or overlays, while others focus on applying adhesives or inspecting final products. Each station has its own rhythm, and together, the assembly line moves like a living organism, each part dependent on the other. Workers are trained extensively, because even a small error, like misplacing a panel by a few millimeters, could ruin the fit or look of a shoe. This training not only covers technical skills, but also safety, since factories are filled with heavy machinery, hot presses, and sharp tools. Nike has faced criticism in the past regarding factory conditions, which is why it now invests in improved safety standards, fair wages in many regions, and audits to ensure compliance with international labor practices. It's a reminder that behind every sleek pair of sneakers lies the labor of real people whose livelihoods depend on this global supply chain. Another fascinating dimension is Nike's focus on constant experimentation. Not every idea makes it to mass production, but hundreds of prototypes are created and tested each year. Some test new cushioning systems, others play with alternative materials like plant-based leather, while others are designed to maximize recyclability. Research labs connected to Nike's supply chain simulate extreme conditions: freezing temperatures, scorching heat, rain, mud, and repeated stress tests. Shoes are bent tens of thousands of times in machines that mimic running steps, or slammed against hard surfaces to see how long soles last. When you buy a pair of Nikes, you're wearing something that has survived brutal tests long before it ever touched your feet. Beyond performance, Nike factories are increasingly places where sustainability is engineered into every step. Traditional shoemaking creates a lot of waste: scraps of leather, leftover fabric, rubber offcuts. Instead of discarding them, Nike pioneered programs like Nike Grind, where these scraps are ground down and turned into new products. You might walk across a basketball court or playground surface made from recycled Nike shoe material. In factories using fly knit technology, waste is reduced by up to 60% compared to traditional cut-and-sew methods. And with new initiatives, some shoes are designed to be disassembled at the end of their life, making recycling easier and more efficient. Sustainability isn't just about waste, it's also about energy and water. Many Nike factories now run on renewable energy sources, and water recycling systems reduce the environmental footprint of production. It's part of Nike's broader commitment to move towards zero carbon and zero waste, which is ambitious but critical in today's climate-conscious world. Factories are the front lines of that battle, where every process can be reimagined to be cleaner and smarter. From a cultural perspective, Nike factories are not just producing shoes, they're producing icons. Think of Air Jordans, Air Max, or Nike Dunks. Each of these models had its origins in sketches, molds, and stitches on a factory floor. Workers may not always know the global impact of the shoes they assemble, but every time one of those pairs hits the shelves and sparks a frenzy of collectors or athletes, it's a testament to their work. Entire communities and subcultures have formed around Nike shoes, from basketball fans to sneakerheads, creating a cycle where the demand for innovation never ends. Logistics is another unseen yet vital aspect. After production, shoes must travel thousands of miles to reach consumers. Nike has built one of the most advanced distribution networks in the world, with massive warehouses equipped with robotics and AI systems that track inventory in real time. Planes, ships, and trucks carry shoes from factories in Asia to retail hubs across North America, Europe, and beyond. What looks like a simple purchase in a store is actually the final step of a complex global journey, one that began with design and ended with a shoebox in your hands. For consumers, it's easy to think of Nike only as a brand, a logo, or a style. But when you pull on a pair of Nikes, you're stepping into the result of years of expertise, careful planning, and international cooperation. Every layer of the shoe, the foam beneath your heel, the mesh around your toes, the rubber under your sole has been engineered, tested, and refined by countless hands and machines. That's why Nike shoes are more than just products. They're wearable technology, shaped by science and human creativity alike. And as the future unfolds, factories will continue to evolve. Already, we're seeing robots take on more tasks, AI predicting defects before they happen, and materials being developed that are lighter, stronger, and more sustainable. One day, you might be able to design your own pair online, and within days, a fully automated Nike micro factory near your city could produce and deliver them. The dream of mass customization, where every shoe is uniquely tailored but still affordable, is closer than ever thanks to advances in factory technology. The story of how Nike shoes are made in a factory is more than just an industrial process. It's a story of innovation, global teamwork, sustainability, and cultural influence. It shows how something as everyday as footwear can represent the peak of science and art combined. When you walk, run, or play in a pair of Nikes, you carry with you the hidden story of design studios, factory floors, and dedicated workers who made that moment possible. And so, as we close this journey through the Nike factory, take a moment to look at your own shoes. Think about the path they took, from a concept on a designer's computer screen to a finished product in your hands. Think about the workers who stitched the panels, the engineers who tested the cushioning, the machines that molded the soles, and the global network that delivered them to your door. Behind every step you take in your Nikes is a world of effort, passion, and precision. If this deep dive into the making of Nike shoes fascinated you, don't stop here. Explore more about the innovations shaping the future of footwear, the sustainability efforts that are redefining global manufacturing, The journey from snake eggs to high-end luxury bags begins in an environment that feels more like a scientific lab than a factory. Inside the snake leather production facilities, every stage of transformation is carefully monitored, from hatching and growth to tanning, cutting, and the final crafting of products that eventually sell for thousands of dollars in elite boutiques. It's a process that bridges biology, craftsmanship, and controversy. One that fascinates as much as it disturbs. The snakes used in these processes are typically pythons or water snakes, bred in controlled environments designed to mimic their natural habitats. Workers ensure consistent temperature, humidity, and feeding schedules, all to optimize skin quality. Eggs are incubated under strictly regulated heat conditions, and once hatched, the snakes are monitored for size, color, and health. The goal isn't simply survival, but perfection. Scales that are evenly patterned, unblemished, and supple enough to become luxury leather. Every scale matters because in the world of exotic fashion, the quality of a single skin can determine whether it ends up as a handbag for a celebrity or discarded as factory waste. As the snakes mature, they're carefully handled, often by trained professionals who have spent years understanding reptilian behavior. Once they reach the desired length and girth, the next stage begins, and it's here that the process takes a darker turn. The harvesting of snake leather remains one of the most controversial practices in the luxury industry. In regulated environments, snakes are dispatched quickly, often through methods designed to minimize suffering. However, the debate about ethical sourcing continues, with animal rights groups questioning whether true humane standards can ever exist in exotic leather production. The industry counters with claims of sustainability. Many farms are certified and audited, ensuring that snakes are not taken from the wild and that breeding populations are maintained responsibly. After harvesting, the real artistry begins. The skins are first washed and treated to remove residues before entering the tanning process, the critical stage that transforms perishable skin into durable, flexible leather. Traditional tanneries use chemical tanning with chromium salts, but high-end facilities often prefer vegetable tanning or hybrid methods to retain the natural sheen of the scales. Workers meticulously stretch each skin, ensuring it dries evenly without cracking or discoloration. It's grueling, technical work that requires a craftsman's eye. Any imperfection could ruin a piece worth hundreds of dollars. Some of the finest leathers are even hand-tanned using proprietary mixtures that remain trade secrets passed down for generations. Once the skin is stabilized, coloring begins. Luxury brands demand precision. Each shade must match their brand identity perfectly. Expert colorists use airbrushes and layering techniques to produce gradients, metallic finishes, or deep matte tones. A single python skin can go through dozens of color tests before approval. The result is a mesmerizing texture, scales that shimmer differently under light, giving snake leather its unmistakable allure. Every piece tells a natural story. No two skins are identical, which makes every final product truly one of a kind. The next stage, cutting, is where art meets geometry. Skilled artisans lay out the skins according to the design of handbags, belts, or shoes, ensuring that the natural pattern flows seamlessly across the surface. A python bag, for instance, may require up to 3 whole skins to achieve symmetry. Cutting is done manually, often with surgical precision. One wrong move could ruin thousands of dollars worth of material. Once cut, the pieces are backed with soft leather linings to reinforce strength and then stitched together using fine threads under magnification. Some luxury brands even require double stitching to guarantee longevity and a flawless finish. But there's an undeniable ethical duality to this process. On one hand, it's a story of craftsmanship, of artisans transforming raw natural material into objects of art. On the other, it's a stark reminder of how industries commodify life in the pursuit of beauty and status. Critics argue that no matter how sustainable the farms claim to be, the concept of raising animals for their skin is inherently problematic. Yet, supporters counter that regulated snake farms reduce poaching, sustain local economies, and even contribute to ecological balance by managing species populations under controlled environments. The reality, as always, lies somewhere in between, complex, layered, and uncomfortable. Interestingly, the snake leather trade also sustains entire communities in Southeast Asia, particularly in Thailand, Indonesia, and Vietnam. Local workers, many of whom have inherited these skills through generations, rely on this craft for livelihood. They handle every stage, from feeding the snakes to cutting, tanning, and exporting the skins. For them, it's not just work, it's cultural craftsmanship, a fusion of tradition and trade. While global consumers see only the glamorous end product, the workers see the continuum, life, death, and transformation woven together in one cycle of survival and artistry. Yet, for now, traditional snake leather remains in demand, especially in high-fashion markets across Asia and the Middle East. Collectors view these pieces not just as accessories, but as investments, tangible representations of craftsmanship and exclusivity. The rarity of authentic, high-quality skins ensures their continued value. Each piece of snake leather carries a kind of primal allure, the connection to something wild, ancient, and exotic. It evokes both fascination and fear, beauty and danger, emotions that fashion has always known how to exploit brilliantly. The entire ecosystem of snake leather production is thus a paradox, equal parts art and exploitation, science and instinct, nature and commerce. It represents humanity's eternal attempt to control and repurpose the natural world, turning something as primal as a reptile's scales into a symbol of luxury. Standing in a snake leather factory, one can almost feel that duality, the clinical hum of machinery mingling with the raw, organic presence of something once alive. Every finished handbag is a story, of hands that crafted it, of scales that shimmered under tropical sunlight, of choices that walk the tightrope between ethics and elegance. How an egg hatches into a creature, how that creature becomes a canvas, and how that canvas becomes a masterpiece carried on the arms of the world's elite. It's a story of metamorphosis, beauty born from nature, and a reminder that luxury, at its core, is often the most complicated expression of humanity's relationship with the natural world. Inside the snake leather factory is not just a story of industrial production. It's a story of contradictions between beauty and brutality, luxury and life, sustainability and exploitation. When you walk through the doors of such a factory, the air is thick with both fascination and discomfort. On one side, you witness the incredible craftsmanship, workers handling every skin with surgical precision, transforming a raw, scaled texture into something supple, glossy, and incredibly valuable. On the other hand, you can't ignore the reality that this luxury begins with the capture and sacrifice of living creatures. The process begins long before the skins even arrive at the factory. Many of these snakes are farmed, raised from eggs under controlled conditions to ensure uniformity in size and skin pattern. This farming process is designed to make the leather industry more sustainable, at least on paper. It reduces hunting pressure on wild populations, allowing breeders to manage growth rates and reproduction cycles. Yet, critics argue that even these farms are not entirely ethical. Questions arise: can any operation that commodifies life to this extent truly be called sustainable? The answer isn't simple. Some environmentalists say snake farming prevents wild depletion, while animal rights groups argue that it normalizes unnecessary cruelty in the name of luxury. Once the snakes reach maturity, the transformation process begins. After humane killing protocols, as the industry claims, the skins are stripped, cleaned, and soaked in chemicals to preserve their unique scale patterns. The tanning process is meticulous. It can take weeks or even months depending on the desired finish. The workers use a mix of ancient techniques and modern chemistry to soften the hide without losing the distinct geometric pattern of the scales. It's this pattern, unpredictable, natural, and irreplaceable, that makes snake leather such a prized material. The next step is coloration. Dyes and pigments are carefully mixed to either enhance the natural colors or create something entirely new. In some high-end operations, the dyeing process is done by hand, with artists painting each piece to bring out depth and texture. This is where art meets science. Every decision, from the thickness of the paint to the type of polish, determines how the final bag or shoe will look under store lights in Paris, Milan, or New York. What began as something primal now becomes a symbol of affluence. However, what most people don't see is the human element that drives this industry. The workers, often from small towns, have honed their skills over generations. Many come from families that have worked in tanning or crafting for decades. Their livelihoods depend on this trade, and despite the moral controversy surrounding exotic leathers, they take pride in their artistry. For them, transforming something raw and wild into an object of beauty is both heritage and survival. They are the unsung backbone of a billion-dollar luxury industry. Snake leather production, when done irresponsibly, can lead to water pollution due to chemical runoff from tanning. As you watch the final products being assembled, the shimmering bags, sleek belts, and glossy boots, it's hard not to be struck by the contrast. These items, often selling for thousands of dollars, once slithered through muddy forests or tropical wetlands. Now, they lie on velvet shelves beneath bright lights. The transformation is astonishing, almost poetic. Each stitch, each polished stroke tells a silent story of metamorphosis, from nature's wilderness to humanity's elegance. The future of this industry is uncertain. On one hand, luxury demand continues to grow, especially in Asia and Europe. On the other, digital fashion, synthetic alternatives, and rising animal welfare awareness threaten to reshape it entirely. Some companies are already experimenting with lab-grown exotic leathers that replicate the exact scale texture without harming animals. If perfected, this innovation could mark a revolution. Luxury without guilt, opulence without blood. But until that future becomes mainstream, the snake leather factory remains a vivid symbol of our complicated relationship with nature. It's a place where craftsmanship and controversy coexist, where art emerges from the most unexpected sources. Watching the process from start to finish evokes a strange mix of admiration and discomfort. Admiration for human creativity, discomfort for its moral cost. In many ways, this story mirrors humanity's larger journey, our drive to create beauty, even if it means taming and transforming the natural world. The snake leather factory is not just an industrial space. It's a reflection of our collective paradox. We crave connection to nature, but also seek to conquer it. We celebrate authenticity, yet reshape it to fit our idea of perfection. And in the gleam of that final polished handbag, you see not just luxury, but the entire story of human ambition, beautiful, flawed, and endlessly fascinating. What if luxury wasn't just worn, but forged under the heat of 1,000 degrees, behind locked doors, under intense secrecy? And what if the gold on your wrist didn't just look premium, but was made from scratch by the very people who engineered the watch itself? Welcome to the inner sanctum of Rolex, where gold doesn't just shine, it's built to endure. Inside the Rolex manufacturing facility, it's not just craftsmanship, it's total control. Every grain of gold, every molecule of steel, every flicker of lume, it's all Rolex. And they wouldn't have it any other way, because to Rolex, perfection isn't just a goal, it's standard procedure. Let's start right at the core of the operation. The Gold Foundry. Rolex is one of the very few luxury watchmakers in the world. Actually, scratch that, it's the only one that makes its own gold and platinum in-house. Not sourced, not subcontracted, not outsourced. Made. Right there, inside the Rolex compound in Geneva. Now picture this, 24-karat pure gold bars, gleaming and heavy, arriving at the Rolex facility. But Rolex doesn't just slap that gold into a case or bracelet. That would be too easy. And way too soft. See, pure 24-karat gold is beautiful, but it's also far too malleable for everyday wear. It scratches, it dents, it bends. Not exactly the kind of material you'd want on a timepiece that's built to last generations. So what does Rolex do? It melts the 24-karat gold, heats it until it's a glowing liquid, then uses specially guarded recipes to blend it with exact proportions of other metals: silver, copper, platinum, palladium. Each of these alloys is added in meticulous ratios to create Rolex's iconic 18-karat golds: yellow gold, white gold, and their legendary Everose gold, Rolex's own patented take on rose gold. But here's the thing, it's not just about color, it's about structure. Rolex engineers these blends so precisely that the resulting metal isn't just beautiful, it's engineered for resilience. Every pore is measured, timed, and controlled. The temperatures are tightly regulated, the humidity, even the ambient air quality in the foundry matters. The alloying process isn't some off-the-shelf operation. It's a ritual, done by trained hands, guided by proprietary data, conducted in an environment that Rolex has optimized down to the last cubic meter. The workers operating these furnaces are more than technicians. They're metallurgical artists. Once the metals are added, the mixture is stirred in exact cycles. It's not about speed, it's about consistency. One wrong ratio, 1 second too long, and the entire batch could be off. Rolex isn't just chasing a gold standard, it defines the gold standard. After alloying, samples are pulled from the molten blend and tested immediately. Right there in the foundry, on-site spectrometers analyze the mix at an atomic level. If the sample doesn't meet Rolex's standard, it's rejected on the spot. No close enough, no maybe later, just out. The accepted alloy is then cast into molds to form long rods or bars, which will later be processed into sheets, links, cases, or bezels. But even this casting phase is custom to Rolex. The molds are specially designed to reduce porosity, eliminate microcracks, and ensure even cooling. After solidification, those gold bars are set aside to rest. Yes, rest. Rolex lets the metal stabilize. It's a step that sounds simple, but is critical. As the metal cools, stress is relieved from the structure. It's like letting bread dough rise, except instead of yeast, it's metallurgy. Then begins the transformation from raw gold bar to usable component. The bars are milled down, cut into blanks, and inspected again. Edges are checked for uniformity, surfaces are checked for density, grain direction is monitored. Rolex isn't leaving anything to chance, and when it's finally time to shape the components, that's where the human touch returns in full force. Craftsmen and women take those gold blanks and start forming bezels, cases, and links. Each piece is cold formed under pressure to maintain metal strength. The forming tools used are Rolex designed, custom built, serviced constantly. Some are even made with diamond-coated elements to maintain edge accuracy. Because gold is soft, but Rolex gold isn't allowed to behave that way. The components are then heat-treated again, going through annealing ovens to bring them to the perfect molecular tension. Not too hard, not too soft. The result? A piece of 18-karat gold that wears like steel, but glows like treasure. And throughout all of this, every batch, every pour, every component is tracked. Rolex logs every stage of transformation for internal consistency. The metallurgy is archived. The performance of each alloy batch is recorded. It's like a lab notebook for luxury. This is how Rolex guarantees that their gold doesn't just shine today, it shines the same 10 years from now, 20 years, 50. The color, the durability, the resistance, it all holds because it was engineered to, not guessed, not hoped, engineered. This entire approach from molten gold to machined case exists so Rolex can say something no one else can. This gold is ours. Every atom, every shade, every edge, controlled, created, and perfected within the walls of one company. This process happens inside a purpose-built foundry Rolex introduced in the early 2000s, and it's not open for tours, not even for industry insiders. No photos, no video. Rolex guards this operation like a Swiss vault, but through carefully controlled disclosures and insider accounts, we now know what happens inside. It's the kind of place that feels more like a high-security research lab than a workshop. Swipe card access, retinal scanners, only essential personnel are allowed beyond certain doors, and everyone who enters is bound by strict confidentiality agreements. Even suppliers who deliver raw materials rarely get to see where that material ends up. Rolex compartmentalizes every aspect of the process. Need-to-know basis. Always. The fewer eyes, the fewer leaks. That's how secrets stay secrets. There are no press visits, no influencer walkthroughs, no behind-the-scenes documentaries. Not even close. The Foundry is a black box, and Rolex intends to keep it that way. The only reason we know anything at all is because Rolex allows just enough information to slip through, just enough to confirm it exists, but not enough to replicate. The culture inside is monastic, focused, quiet. There are no loud machines whirring constantly. The equipment is advanced, but the environment is surprisingly calm. Rolex believes precision thrives in stillness. Tools aren't left out. Everything is cataloged, cleaned, stored. The place runs like a Swiss watch, pun fully intended. Even small tasks like transferring metal samples are done with a kind of ritualistic care that borders on obsessive. Visitors, when they are granted access to the building's outer areas, are watched closely. You won't find anyone wandering off or pulling out a smartphone. It's not even allowed inside most sections. The entire perimeter is controlled, cameras, sensors, and layers of security. And Rolex doesn't just keep this process locked down for show. It's because the techniques used inside the Foundry, the recipes, the casting methods, the finishing techniques are 100% proprietary. Competitors have tried to reverse engineer Rolex alloys for decades. They've gotten close, but never quite there. Because without knowing the exact processes used, the atmospheric conditions, the resting periods, the microscopic tests, the results are always just a little off. Rolex knows this. That's why they don't outsource. That's why they don't brag. They just work, quietly, meticulously, behind those thick Geneva walls. Even the Foundry's physical location within Rolex facilities isn't promoted. There's no big sign, no separate entrance. From the outside, you'd never know it was there. Just another anonymous-looking building in a quiet industrial zone. But inside, that's where the transformation happens, where raw gold turns into Everose, where alloys are born, where case blanks take shape, where the materials that define Rolex's legacy are literally forged. This is where Rolex's magic is made, not in marketing decks or fancy boutiques, but in fire, pressure, and secrecy. The Foundry is the heart of the brand, and it beats behind locked doors. Foundry men melt 24-karat gold over roaring flames. That molten gold is then poured through a sieve, creating droplets that fall into vats of water. The instant cooling hardens them into beads of 18-karat gold. Those beads are the starting point for Rolex's cases, bezels, crowns, and bracelets, and that's only step one. And the same extreme level of control applies to Rolex's other materials. Take oyster steel, for example. This isn't just any steel. It's a 904L stainless steel, an ultra-resistant high-performance alloy that Rolex has used since the mid-80s. 904L steel isn't easy to work with. It's tougher, more durable, and more resistant to corrosion than the more common 316L used by most other watchmakers. But Rolex wasn't interested in what's easy. They were after what's better. 904L, or as they call it, oyster steel, offers unmatched brilliance when polished. That mirror-like shine? It doesn't come cheap. Before Rolex even begins shaping it, this steel is examined under microscopes. Every grain, every layer. If the microstructure isn't right, it doesn't make the cut. Once approved, the metal is primed, hardened, and refined again. Then finally, expert polishers unlock that signature glow that sets Rolex apart. And then there's Rolsor, another Rolex original. It's a marriage between oyster steel and gold. Toughness meets elegance. Rolsor combines the core strength of steel with the nobility of 18-karat gold, usually seen in the bezel, crown, or center links of the bracelet. It's become a visual signature, that seamless blend of luxury and durability. And speaking of innovation, what Rolex does with light is equally impressive. Enter Chroma Light. Back in 2008, Rolex unveiled this breakthrough display tech. During the day, the markers look crisp and clean, but at night, the glow is unmistakable, a deep, piercing blue, not the green lume you see on most other watches. Chroma Light is more than just good looks. It's engineered to store ambient light energy, then release it slowly and evenly in dark conditions. It's a custom-developed substance made from a blend of aluminum, strontium, dysprosium, and europium, which is first powdered, then heated, then blended with resin, and applied by hand to each dial marker and hand. This level of precision is what defines Rolex. From metals to lume is either developed, refined, or crafted entirely in-house. They don't chase trends, they engineer timelessness. Take RLX titanium, for instance. Rolex could have easily adopted standard titanium years ago. Lots of brands did. It's light, strong, corrosion-resistant, but Rolex wanted more control. RLX titanium is a special grade 5 titanium alloy, and Rolex spent years studying its properties before deciding to bring it in-house. Now, think about all these materials: gold, steel, titanium, platinum, and imagine the coordination it takes to blend them into a single cohesive timepiece. That's why Rolex doesn't outsource its research and development. They have full-scale professional labs on site, chemistry labs, physics labs, stress testing chambers. Watch components get tested under brutal conditions: extreme heat, cold, moisture, shock. Each part gets tortured before it ever ends up on a customer's wrist. If it breaks, it goes back to the drawing board. If it survives, it earns the crown. This obsessive attention to material science is why a Rolex feels different, why it lasts, why it means something. It's not just the logo, it's the years of metallurgy, testing, and hands-on craftsmanship behind every element, even the ones you never see. No shortcuts, no compromises. Rolex controls everything, and this control means that when a $50,000 Daytona or Day-Date rolls off the line, it's not just a luxury object. It's a material marvel, forged from raw elements reshaped by science and perfected by hand. So next time someone says it's just a watch, show them the Rolex foundry. Show them the steel that's scanned on a microscopic level. Show them the rose gold that never fades, the glow-in-the-dark markers built from rare earth elements, the titanium that shimmers like silver even after years of wear. Because a Rolex isn't just built to look good, it's built to outlast, built to perform, built to live. And when you wear one, whether it's a classic Datejust or a cutting-edge Yachtmaster, you're not just wearing gold or steel. You're wearing decades of research, an obsession with detail, and a relentless pursuit of mastery, all forged from a single bar of gold. If you found this deep dive into the Rolex Gold Factory as fascinating as we did, make sure to like, subscribe, and hit that bell icon so you don't miss out on more behind-the-scenes stories of craftsmanship, luxury, and innovation.